All right, guys, we've got kind of a long one today. We're talking about transportation systems. And it's long because I think they kind of just repeat a lot of things. So I'm going to try to kind of pick and choose what we spend the most time of our conversation on. But I think a lot of this is stuff that you guys kind of already know and is a little bit of common sense. So I'm hoping that I can shorten some of this a little bit for you guys. So we're just talking about transportation systems. We know what transportation is. You can get from one place to another, whether that's walking, driving, biking, flying in an airplane, taking a boat, taking a train. All of those are vehicles, right? They're ways that you can get from one place to another. But they're not the only thing that we need to be able to get from one place to another. We actually have what we call transportation systems, which is everything that has to be in place in order for you to get from one place to another. So, for example, airplanes are awesome, but without a runway in an airport, you're not getting anywhere. You have to have a runway for the airplane to be able to take off. You have to have air traffic control people for them to make sure that there aren't any crashes happening. You have to have weather people that are making sure that the weather's okay to fly. You have to have the pilot. You have to have the flight attendants. You have to have the engineers. Like, all of that goes into your transportation system. Same with roads. So, you might think when you're going to a friend's house that it's just going to a friend's house, but you're on a transportation system. And so, yes, you have the car, you have the gas that goes into the car, you have the gas stations that are on the way in case you need fuel, you have the roads, you have the speed limit signs, you have the other signs that are involved, you have mechanic stations. All of those are part of our transportation systems. And so transportation systems can just be really complicated because there's so much to think about when they're designing them. For example, a lot of our conversations about transportation systems recently have been in relation to the problems we've had with fossil fuels and overusing them. So we know that cars and buses that run on gas and diesel are polluting our environment. We also know that electric cars are awesome, except they're still harming the environment because a lot of the electricity is used from fossil fuels and we don't have enough of them, right? And so a lot of people have started going towards biking, and using a bicycle is great, but it sucks for long distances and horrible weather. So there's just a lot of thinking that goes into trying to figure out what's going to work best for a community and how they're going to make those things safe and work together. I kind of wish that this lesson was more connected to our fourth grade friends, only because our fourth grade kiddos in social studies have spent so much time talking about transportation systems being built, specifically in Indiana history, but also in the U.S. And I just think it'd be cool for them to connect it. But you guys have already learned about a lot of this, so you're just going to need to kind of pull from your background knowledge and the things you kind of already know and just kind of use that to help you out. Vehicles are used for a couple of things. They can either be to move people or they can be to move items. And so like cars and taxis and bicycles and motorcycles, those are usually just people. But trains, planes, trucks, vans, those can be used for people or for items. They can do either. So there it goes. So we're going to start out by just talking about how different systems meet different needs. So when you're thinking about a transportation system, you're usually going to think about a specific type of vehicle. You're going to think about a car or a train or a plane, or whatever pops into your head. And it'll usually be whatever you use the most often. Things that you use less often, like a plane or a train, might not pop into your head automatically when you're thinking of vehicles. But all of them have transportation systems that help us function. So we talked about how when you go to a friend's house, you have all of these things on the roads that help get from one place to another. Same with airplanes. Their transportation systems, they've got the airports, they've got rules about flying, they've got the system to fuel it, they've got radio and radar systems and all of that stuff. So in countries like the Netherlands, Japan, and China, bicycles have really been a matter of national importance. And so they have really prioritized making sure that there are space for those, as well as like cars and trains and planes like we often see. In the United States, we're starting to go that direction. We're starting to see that bicycles are being used more often, and that there's a lot of positives to that. Some places of work install like shower areas so that if you take a bike to work, you can get cleaned up and changed and, ready for your job. Obviously, it's not very easy to bike across town in a suit, and you do get sweaty. It is exercise, so they kind of have these stations set up so that people can get cleaned up. A lot of cities are starting to develop bike lanes or bike paths or specific places that bikes can travel safely. And others, like we even have in South Bend, we had the Lime bikes, right? So a lot of cities have these bikes and scooters and things like that you can use for a short amount of times or for when you need them in case you don't own one. So different systems meet different needs. There's a lot of advantages and disadvantages to all of them, and they all have to be thought about. So like road and highway systems are super convenient when you're talking about cars and buses and taxis. But they're also what becomes most commonly like the most congested, like has the most traffic. And to keep up with roads is a lot of money. So those are some downsides. Flying, taking a plane, you can go really far really quickly, but it's a lot more expensive than ground or water. And with increases in the amount of people traveling, it can kind of really slow things down. The security measures that have had to been taken can really slow things down. So if you're not going a very long distance, it's not always the fastest option because of all the other things that you have to do in order to even get on the plane. Water travel is good as far as, going long distances with lots of space if you have big cargo, but it's super slow, super slow. So there's a lot of pros and cons to all the different transportation systems, and those things have to be thought about when they're picking one for a city or for an area to develop. So, like, reasons why people might choose certain things come down to social, economic, and environmental factors. In Portland, Oregon, they were really concerned about the obesity issues. They were concerned about the congestion of the roadways, and they were concerned about the cost of everything that was going on to fix the roads, but then also for individuals. And they tend to be very concerned about the environment. And so they decided when they were revamping their transportation systems that they were going to put a large emphasis on biking. And having a lot more biking options for that. So those are some things that people will think about when trying to decide what kind of transportation system to go forward in. When we're talking about transportation, we have to think about fuel. Gas pretty much does it all. And we know that gas is not good. Most of it is petroleum based. And it's a fossil fuel, so it's non-renewable. One day we will run out. It will happen. And so another reason to go from petroleum, not only because it's non-renewable, is because of its cost. It's really expensive. We're kind of seeing the opposite effect right now because we're in kind of this economic crisis, and so gas prices are dropping significantly. But normally petroleum is pricey. It's not cheap to go fill a car with gas, and it just keeps continuing to increase over time in price, especially because we know someday it's going to run out. And then the biggest reason, in my opinion, is because of the pollution. I mean, we know by this point it would be pure denial to try to say that we aren't impacting our environment with the amount of gas that we're using. And at some point, that has to be considered if we're going to keep living on this planet for ever and ever. If you want your great grandkids to, be able to use this planet, then at some point that has to be thought of. So because of all these problems with petroleum, people are trying to look to develop things that don't use that. We have a lot of cars that have started running on electricity. There are pros and cons to that. It's better for the environment, but a lot of our electricity still comes from fossil fuels, so we're not quite getting away from that non-renewable issue here. But it is a good step in the right direction. A lot of public transit and trains have been put in because people can then use those versus driving their own cars, and those things can take a lot of people in one trip, and so you're reducing that amount of fuel that's getting used. So there you go. We're going to kind of get into the nitty-gritty science part of motion right now. So we know that the whole point of transportation vehicles and systems is to get from one place to another, right? Okay, how does that happen? So we're going to talk about the forces of energy that affect the motion of the vehicles that we have. So some forces can cause an object to go forward, some can cause an object to slow down, and some forces purely keep an object on the ground or keep an object in the air. So we're going to kind of talk about all of those pieces. So in cars, a lot of those gasoline engines and diesel engines, those are what's causing that vehicle to move. In a bike, the force that our legs are putting down on the pedals is causing the bicycle to move. We have things nowadays with magnets and electrical charges that are creating ways that other trains and electric cars are getting propelled forward. When we talk about forces that slow things down, the main one we're talking about is friction. Friction is that thing where two things rub together, right? It causes that resistance. If you rub your hands together really quickly, they're going to get really hot, right? So that friction is what we're using to kind of slow things down. It can be produced by air resistance. It can be produced by brakes, and it can be produced by gravity. Gravity is really the primary force that we use to keep all our vehicles on the ground. That's our main idea here. Meanwhile, lift is like the opposite of gravity. Or not the opposite of gravity, but it does the opposite of gravity. Gravity keeps us on the ground. Lift is the force that keeps us up in the air. Another upward force is buoyancy, which is what keeps us above the water in a boat. It's what allows us to be able to float. So there are special terms that describe the forces that work when an airplane is in the sky. The upward force is called lift. The propulsion force, that move forward, is called thrust. And then the force that slows us down or stops us is called drag. For pretty much all transportation vehicles, we talk about thrust and drag. But lift is pretty exclusive to airplanes. All of that has to be considered when an engineer decides to design a transportation system. They have a pretty specific design process. Generally speaking, they start with kind of mapping it out and creating a vision that people can see. And during that, they have to think about everything we've talked about so far. They have to think about what the community needs, what the community goals are, what the world goals are. They have to think about the cost effectiveness. And then they have to start thinking about, okay, where is this transportation system going to? What's the end point here? And if in getting to that end point, they have to cover bodies of water or things like that, they have to think about building a bridge, in which case they have to think about how high is the bridge going to have to be? What is the soil like around the bridge for them to be able to design that and put that into? They have to think about the population. How many people is this system going to serve? All of those are things that they think about when they're designing any kind of transportation system. And then they have to follow all of the rules and everything that are in place in order to make sure that they're up to all the safety precautions and everything that has to be done in order for them to really begin even starting to build that transportation system. All right. Recap time. Why do people need transportation? We all have things to do. We want to go places. We want like items to be delivered to us if we order off Amazon. Those are all things that, are motivators for why we need transportation. And then transportation systems are used to connect all of the things that we need in order to get from one place to another. How do different forms of transportation meet people's transportation needs? All sorts of different ways. If your need is to go a short distance and you care about the environment, then you're going to bike. Awesome. In bad weather, you're going to wish you had a car because a car is going to get you there without you getting wet or soaked or whatever. If you need to go really far away in a short amount of time, you've got an airplane. If you need to travel longer, or if you're shipping a lot of items really far away, then you're looking at trains and cargo ships. So lots of different ways that transportation meets different needs. Factors that influence a community choice of transportation system, tons, right? Gasoline, the cost of gasoline, the use of gasoline, how quickly and efficiently can it be built? How quickly and efficiently can it be maintained? How can we make sure that we're giving low cost options with bike paths and things like that? So all of that stuff is considered. And then what forces affect the motion of transportation vehicles? There are 4 forces. We have up, down, forward, backwards, right? Those are our 4 directions that a force can go. The engine of the vehicle is going to provide the force forward. Friction is going to provide the force backwards. The weight of the vehicle combined with gravity is going to provide that force down. And then lift from air or from water and buoyancy is going to cause something to go up. And by understanding all of those forces, engineers are able to really work hard to develop things that work well for us and get the job done. And yeah, that's all I've got for you.